Okay, so we're going to be working now with a triangle that is not a right triangle. You can see here in this diagram that we're not told we have a 90-degree angle. So this question says, Kara is standing in the center of a field. From where she's standing, she can see 4 posts at different positions on the field, as shown in this diagram. How far apart are posts A and B to the nearest tenth of a meter? So this one is one we're going to have to solve for a couple different things in order to get what is actually asked for, which is the distance from A to B. C stands for where Kara is standing in the field. And you can see we have this diagram. Now, if I look at this left triangle, I only have 2 pieces of information. I have angle B and side B. But you know that in order to find anything, we need 3 pieces of information. So I can do nothing with this left triangle right now. But if you look at my right-hand triangle, I actually have 3 pieces of information, all 3 side lengths. This might be helpful. If I remember from grade 9, or even grade 7 or 8, my CFZ patterns, I know that angle C on the right is going to equal angle C on the left. These are alternate interior angles, so they will be equal. So I'm going to start off by finding this right-hand angle, and then I can start using my left-hand triangle. I have all 3 sides, so this will be a cosine law question. And I'm going to be starting with cosine of angle C. So remember to pick the right formula. This one is if I'm looking for an angle. So remember with cosine law, it's important you start with the side across from the angle you're solving for. So I'm going to start with 9. And then I'm going to subtract my other 2 sides, which are 10 and 8. And in the bottom, I'm only repeating my final 2 numbers up here, not the 9. That only gets used once right here in the first position of my formula. So then I'm just going to actually plug all of this into my calculator and see here what I get for cosine of C. I will use my fraction button on my calculator, but you guys will have to get comfortable again, remembering how you're going to plug all of this in to make sure you get your final correct end answer. So I'm actually getting my final, or my answer to be 0.51875. And hopefully you're remembering Mrs. Reed promised to never give you an angle less than 1 degree. So there's something wrong here. This is equal to cosine C. So let's get the cosine off. And on my calculator, that's going to look like cosine -1. And I will use my answer button so I don't make any silly errors putting that number back in to my calculator. So cosine -1 of answer, and I actually get this to be 58.75 degrees. I will just call this 59 degrees. So this is 59. Alternate interior angles are equal. This is 59 degrees. So shift over here to this left side triangle. I already told you earlier I have angle B and side B. Loop of information right away indicates sine law. And I'm solving for a side length. So I will make sure my sides go on the top in the numerator and my angles go in the bottom. So side B is 6, angle B is 72. I don't know A to B, but I know the angle across from it is 59 degrees. So make sure sides go in the top when you're solving for sides, angles go in the bottom. X is my variable. It's being divided by the sine of 59. So I'm going to multiply both sides by sine of 59. So I'm going to do 6 divided by sine of 72. Make sure you have to close any brackets necessary in your calculator, and times by sine of 59. And I get 5.4. Because this calculation is all multiplication and division, it doesn't matter the order that it goes in. So you could do sine of 59 times 6 divided by sine of 72, or kind of whatever order that you want to put that in. Make sure sine of 59 is multiplication, 6 is in the numerator, and sine of 72 is in the denominator, or its division. I have found what I'm looking for. This side length, A to B, we just got here as 5.4. And so that is the final answer that I'm looking for.